do-it-yourself workshop here in the Conservation District presented by Seeds. Couldn't do it without our volunteer, Jack Burnett, and our presenters, Blair. I saw you a second ago, Blair. Where'd you go? Blair and his brother, Bill. So we're really grateful to all of our volunteers that help make these events happen. My name is Jocelyn. I'm the Executive Director for Seeds. And Seeds is a local nonprofit organization that promotes energy efficiency, renewable energy, and sustainable living in this region. And we do it both for the improved health of the environment and our local economy. Anybody that has any questions, please see me. We're going to get started. I want to get right to it. We do have some information at the front desk if anybody's interested, a little bit more about Seeds, why we do what we do, and some of the other programs that we have. But our educational forums are one of our most visible activities in the community. We do several a year, and if you're not on our email list and you'd like to be, please see me or sign up on one of the clipboards. That will always let you know about our free events. We offer free residential energy assessments to residents of Wayne and Pike counties. If you're interested in this free service, do let me know. Sign up, space is limited. We hire local high school students for this job to help us, so you'd also be helping them develop their training and skill, and we have someone here tonight that's been a part of that program for years. So if you have questions about that or you are interested in signing up, please see me. Lastly, before we get started, I want to just let you know that we have learned about some really great opportunities out there to help our local nonprofits with energy costs. Anybody has a nonprofit that they love and they'd like to learn more about that, please let me know. There's some really exciting offers out there right now. But I will pass this, I'll pass the evening right on to Jack. Jack Barnett is a Seeds board member as well as the president of the Clean Energy Co-op, and he's going to kick us off tonight.
All right, thanks for coming, everyone. So if there's any questions anytime, let's just make sure we have an interactive discussion. This is a workshop. So we wanted to make it very interactive. I'm going to start, and then Blair's going to come up and do the hands-on stuff. So we're going to kick right into it. So tonight, it's a 2-day workshop. So tonight we're going to cover the economics and costs, an intro to the basic, what a system is and how it's assembled, what its components are, a little bit about the paperwork and permitting. We're going to mostly talk about Pennsylvania. But if you live in New York, it is a little different. Some of the same steps, but not always. And then we'll get into the hands-on part with our demo roof, how to mount it, how to size it, and do layout. And tonight we'll probably get through the kind of basics of racking installation. And then tomorrow, we want you to come in, and if you're interested in doing your own solar, or even you want to have solar looked at on your house, we want you to take a homework assignment. And that says to look at your roof or the ground area where you might do a ground mount and draw a sketch of that area. How big is it? If you can measure it, that's perfect. If you can't measure it, then estimate. Where are the shading and how's it oriented to east, west, north, south? We'll talk more about it, but plan on bringing that with you tomorrow night if you're interested. And we can walk through it individually a little bit. And at least you get in the thinking process of what you need to do to set up the system. And then tomorrow we'll talk about more about the paperwork. Unfortunately, it is a good bit of a paperwork problem. We'll review the racking for anybody who might show up tomorrow that didn't get into here tonight, and it's good to see it again. Then we'll talk about inverters and the actual panel installation, wiring, grounding, commissioning, and how to do ongoing maintenance. So it's a very busy time, but the way to make this successful for all of us is to be very interactive. Ask lots of questions. Both Blair and I are glad to take questions anytime. Okay, what are the most important considerations? Well, it's this quality of the site. And the two main factors are the orientation and the shading. So orientation, you want it facing south. In the northern hemisphere where we live at about 42 degrees latitude, the sun sets in the west, rises in the east, and crosses the sky on the southern face of the hemisphere. So yesterday was the solstice. That's the point where the sun reaches the highest point at noon. And the sun sets actually in the northwest So it doesn't rise directly east, it sets way north in the west. It sets way north of west and rises way north of east. So you have to be thinking about the shading of it. It's not easy because all it takes is a little bit of trees, a satellite dish, even electric lines that might be shading that spot are very hard to tell. And the sun moves from the winter. Of course, in the winter solstice, it's 50 degrees further south at noon, and even sets in the southwest and rises in the southeast. So you don't get nearly as much daylight in the winter. And the best way to measure it is with a device. There are a couple of them on the market, but this is one that's fairly easy for us to use as amateurs. It's called the Solar Pathfinder. And it's the best thing about it is it can measure the shading that spot gets all year round in one measurement. Okay? So you don't have to be there all year round to measure it. You can take one picture of this device when the sun's shining, and you get something like this image up here on the picture. And it may be hard to see in the dim lighting down here. But you can see that the shade is on the left-hand side and the open sky is on the right-hand side. Well, what that says is that location gets shade every morning, every month, until 11 a.m. There's no sun hitting that spot before 11 a.m. any month of the year. So that's not going to be a good site for solar, just because it needs about 5, 6, 7 hours of sunshine is best every day of the year. And certainly in the summer, you should be getting at least that, and maybe a minimum of 4 in the winter. Yes?
Sometimes the shade leaves, which you don't have.
Yeah, but you just don't have the branches, and that's still enough to make PV difficult to use. You know, our sun is a great thing, right? It shines real intensely. You know, we've got lots of intense sun coming through the windows here. But if it's dimpled, that's reducing the intensity of that energy that's hitting the panel. And the panel is not a linear production device. Being an engineer, it's an S-curve. So it really needs to reach a threshold of light energy hitting it to be a good production. And leaves, even tree twigs, a line of power line through the panel can cause it to drop production by more than 20%, sometimes to like 80%. In mornings, twilight, you'll still get some wattage out of it, but you won't get much. It really takes that full sun to produce its full power. So that's the biggest thing. And as Jocelyn mentioned, the energy efficiency assessments, SEEDS also offers a program to SEEDS members. If you're interested in having solar on your home and you're worried about shading, myself and one of our other volunteers is glad to come to your site and look at it, bring our Pathfinder, and make some measurements and give you an assessment of that site.
And that is free to any SEEDS member.
Right.
SEEDS membership is $10 a year.
So if you're interested in that, and maybe more so after tomorrow's, and you've seen the whole scale of this thing, sign up with Jocelyn, and we will be glad to try to get you scheduled here as quickly as we can. Tonight, we're doing this program as a do-it-yourself program, and that's important for cost, but a lot of people may be here just because they want to learn about solar, and that's a fine reason to be here as all. Because one of the issues, the second issue is kind of sizing the system. When you size the system, you're usually constrained by one of two things. Total budget, how much can you afford to invest in it, or the space on the roof that's clean of orientation correctly and not shaded. So those are the two kind of limiting factors in the process. Let's talk about cost. Kind of two rules of thumb. If you're doing a professional installation, there was a report from the Solar Energy Industries Association that looked at all 50 states for data from 2014 and 2015 and said, what is the average cost of a solar installation on a residential roof. And in Pennsylvania, it was $3.70 per watt. And that's watt of capacity. We'll talk about this as we go. That may sound cheap, but when you realize that an average system is 5 kilowatts, that's 5,000 watts, you've got to multiply that too. So it's over $15,000. Okay, now if you do it yourself, you save a good bit on the labor, but you still got to buy the equipment. And the equipment is the biggest cost here. And that's probably $2 a watt, maybe more. We're going to talk about a type of inverter that's a little more expensive than the cheapest type, but it's easier to do for home do-it-yourself projects. So, 2 to 210, 215 a watt is probably the minimum you're going to pay, or the maximum you're going to pay for equipment. But some equipment is premium equipment. You can buy premium panels that give you more wattage per square foot. So those will cost more. If you have a complicated roof, you might have to buy extra railings, extra lag bolts, you name it. Plus you've got to deal with local permitting and pay the permitting fee for your municipality or your homeowners association or both. So those costs vary a lot. My township charges 1.5% of the cost as the permitting fee. So that racks up really quick.
Are you talking about grid connected system?
We'll talk about that in just a minute. So, to be certain on the cost, you can use these rules of thumb once you size the basic system. But to really get a cost, you should have one or more professional installers look at it and get a quote from them, or an estimate. Most everybody will give you that with no cost. My recommendation is to get a NABCEP certified installer, and Blair happens to be the only one in our area, although I saw on the NABCEP website, there is one down in Milford, but I have not been able to contact him. And there's one in Wilkesboro. But those are the only 3 NABCEP certified installers currently in the database in our area. But that says they have been gone through a mentoring program, they've taken lots of classes, they've been certified by the National Board for Energy Professionals, Renewable Energy Professionals. Okay, let's get a little bit, oh yes, Chuck?
Just a question on the cost. Can you give a kind of a thumbnail sketch of how that professional installation cost has varied in the last from 8 years ago to now, and where it might be going?
Good point. Thank you, Chuck. The cost of equipment has dropped by more than 50% in the last 4 years, maybe 5 years. And so the prices that if you've got a price quote 3 or 5 years ago, throw it out. The equipment has dropped radically, mostly because Asia and parts of Europe, and particularly Germany, are mass producing solar panels like mad. So they've ramped up the factory capacity, they've introduced a lot of capacity, and American manufacturers have suffered because they couldn't price their panels as low as some of the imports. Right now there is a tariff, punitive tariff against certain countries, mostly China, because they were judged by the World Trade Organization as dumping their panels on the market. But that tariff is, I think, supposed to end at the end of this year or next year. I can't remember exactly. But it was a 2-year punitive tariff increase. We could expect to see prices still fall over the next year, but they may not fall as fast as they would if that punitive tariff was not in place. Because China is going on solar panels like that. I mean, the Chinese government has switched from a coal-oriented energy program to a renewable energy program, like on a dime. Their government can switch policies very quickly, and they are ramping up their production still. So, unfortunately, the labor costs and the other costs, the balance of the system, the aluminum and other things, are not necessarily dropping as fast. But the labor still is getting simpler as these systems become more and more programmatic.
Excuse me,
Yes?
the Chinese and the European solar, are they comparable in quality? Because obviously a lot of the Chinese stuff is garbage. I don't want to put something on my roof and then have to take it off in a year or two.
Yeah. Most all of these are warranted for 25 years, and many of them are big names. Some of them are not names we recognize because they're imported names. So I don't, Billy or Bill, you want to comment on any problems you've had with any of the manufacturers? You deal with lots of them.
Not really, because we haven't gone down that road of, we're usually, when we look at the spreadsheet of panels and what they cost, we don't go low end. At first we were doing just strictly American made, and then, like Jack said, those things swallowed up, and it's like, it's hard to find American made anything for the systems besides the racking anymore. So panels themselves, we usually stick with the bigger names, like you said, like Hyundai makes a real quality panel. Canadian Solar, Shot Solar was a German company, but they pulled out of America too. But they were, yeah, I think that's what's on your roof.
Yeah. LG.
LG, yeah, LG is a good one.
And there are a few American companies, but they tend to demand a premium
And are
price.
the inverters made by the same companies?
No, not usually.
Okay.
I'm not sure if any inverter is made by a panel company or vice versa. Somebody else makes it and they might just brand it in their own name.
Thank you.
Sure. Okay, let me talk about the ways you make your money back, just economics. So if you pay $16,000 for a system, that's a lot of money. The good news is you get 3 ways to make the money back. The first is a federal income tax credit of 30% of the cost. I'll talk about that a little more in a minute, but let me cover the other 2 and come back to that. The obvious one is you're generating your own electricity. And so that means you're not buying as much electricity from the utility as you would otherwise. We'll talk about how net metering works, which is the structure in a minute. But that means, basically it means you're selling to yourself first. Okay, so your price of selling is 0 because you've already installed it. There's no fuel to burn. It's not like you're buying natural gas or fuel oil or anything like that. Your system's on the roof, it's generating electricity as long as the sun's shining. So you don't pay the utility for that many kilowatt hours. So you're going to save money there. Today, in this part of Pennsylvania, with PPL's default rate, plus the generation and the distribution charge at kilowatt hours, it's about 11 cents a kilowatt hour. So a 5 kilowatt capacity system produces about 5,500 kilowatt hours a year. We can talk more about the details of that, and I put this handout that talks about the details of going through that calculation if you're interested in it. I'm not going to go through it today. And so that 55,000 kilowatt hours times 11 cents is what you save annually from the utility bill. You'll have that, not have to pay on the utility bill. Okay, and in Pennsylvania, you can also sell something called a Solar Renewable Energy Certificate, or credit. Unfortunately, these are not nearly as valuable as they once were. What it means is your energy is sold on a separate market. So the energy itself you're using, but the green characteristics of that energy, you can sell to somebody else who might want to claim their product is green. So it sounds a little weird, but it's known as an offset. And in Pennsylvania, the public utilities are required by law to sell a portion of their electricity as solar electricity. It is only going to be 0.5% of all their annual use load in the year 2021. So 0.5% is pretty small, 0.5%. And unfortunately, in Pennsylvania, anybody who is in the region, it's the utility region, which includes Pennsylvania, Maryland, New Jersey, parts of Ohio, parts of Kentucky, parts of North Carolina, parts of Virginia. All of those solar systems and all that territory can sell their SRECs into the Pennsylvania market. And so we have been flooded with systems, and the value of an SREC now is about $12 to $15 per megawatt hour. So if you're a 5K system, you produce 55 kilowatt hours, that's 5 megawatt hours, 5.5 megawatt hours a year. That's all of $50, $60 a year. That's not much, but it's something. Okay, so those are the three things. There may also be grants, especially for small rural businesses, farms, for example, and other programs where you can get some help. New York State has a huge set of programs for New York State residents. But in Pennsylvania, our program that used to be in effect called the Sunshine Program was unfunded in 2013. All the money was consumed and it has not been refunded. So there is no programs for Pennsylvania residents. Okay, the federal income tax credit is, as I mentioned, is 30%. It doesn't have to be on your main home, but it has to be a residential system. It's only for the actual money you spend, so you can't capture do-it-yourself labor against that. And the good news is last year when we gave this program, we were all worried because the credits were going to expire at the end of 2016. The good news is they've been extended by Congress through at least 2021 at 30% and for 2 more years at a reduced percentage. So you've got a little more runway if you want to get this 30% tax credit. The form you file is $56.95 and you must have taxable income offset. That's why it's a tax credit. But you get all of that money back in the sense that you don't have to pay taxes dollar for dollar. That 30% of the cost. Okay. Any questions on the tax credits or SRECs? Okay. I mentioned net metering, and this is some complicated section a little bit, but the idea of net metering is that when you're hooked to the grid with a solar system or any kind of generation system, you can run your meter backwards. Okay? What that means is when the sun is shining on your solar system and you're producing lots of electricity for that 5 to 8 hours a day, in your house load, the amount of energy you're using in the house is probably not nearly as much as you're producing. The electrons will go to your load first, inside your house, behind your meter, and you won't be drawing electricity from the grid. Instead, the excess electrons will go out the grid, out the meter, and out the grid. So it's a two-way grid. Not usually our things thinking about how electricity works, but it is. What you're doing is you're building up a credit when the meter runs backwards, right? So while you're producing lots of excess electricity, the meter runs backwards. The sun sets at night, the meter runs forwards as you consume your credit. And that happens day after day, season after season. So you produce a lot more credits in the summer because the sun is higher, it's longer days. And in the winter, you tend to use those credits more because we have cloudy storms, snowfall, and other things. So that's how net metering works, except for some subtleties. At the end of your billing cycle in May, the utility will give you a check for any excess credits you have at that point in time. Now, for me, my solar system is the most productive, actually usually in early April when there's still snow on the ground and it's cold. The sun shines really nicely on the snowfall on the ground. It reflects up on the roof, and PV systems there's a semiconductor, likes cold weather, it hates hot weather. It's actually more efficient in cold than it is in hot. So I get the best day of the year will be in April typically. So I've got a small credit I built up in April that I have to get a check from. But that check is not the full value of that 11 cents I mentioned. Okay? They will only give you a check at the rate to compare in Pennsylvania. So today that's about 7.5 cents instead of the full 11. Okay? I'd much rather have my credit carry forward, but that's what they get to do. Now, real important, especially since we were handing out the PA switch program, if you have an alternate energy provider, not PPL, and you're interested in having a solar system on your home or at your home, you must check with that alternate provider to make sure they support net metering. They're not required to do so in Pennsylvania. It's optional. PPL, as the distribution utility, is required by law to do it. So they will support it, and they have a great program. But if you're using an alternate provider, you may have to switch back to PPL to be able to use net metering. Okay? And that some contracts have a penalty for early cancellation of that contract. So you need to look at your provider carefully if you've chosen an alternate provider.
Do you know if New Jersey has a law like that?
I don't know. Blair, do you? New Jersey?
Yeah, they're like that too.
They're the same. Okay. Okay. So that's.
So any primary electric, I know, like Equinox First Electric?
Yeah, I don't know.
Penelec, yeah, they're.
Penelec. Yes. Yeah, Penelec is any distribution utility is required by law, except for co-ops. I don't think we have any co-ops in our area,
No.
but there are some out in Sullivan County, Pennsylvania. They're optional. But okay, good question. Okay, I want to get into a little bit into what makes up a PV system, and then we're going to have Blair really get into more details with you. Okay, I mentioned already that the panels are a semiconductor material. They're actually much thinner than the panel looks to be. They're almost paper thin. We just put, when they manufacture a panel, they put on a backing and a glass cover so that it's protected from the weather, it doesn't corrode, and it's easier to handle, it doesn't bend and break. So these are panels that convert the sunlight into direct current electricity. So like a battery, it's a direct current. It's not alternating current like most of our household equipment and appliances. So you also need inverters to convert the direct current into AC current. Our system we're going to demonstrate today and talk about in this workshop is a micro inverter system, which means we put one inverter with every panel mounted together. And the reason for that is it's really simple. It's all the wiring you do is AC wiring, so if you've done any kind of electrical work on your home, it's very familiar to you. If you're doing what's called a string inverter or a macro inverter, that has DC wiring at high voltages, 600 watts, 600 volts, that requires a whole section of the electrical code to be compliant with. And it's much more strict on things you can do with that. So to keep it simple for a do-it-yourself project, we use microinverters. They're a little more expensive than a string inverter might be for a system, but they are much easier and more flexible, especially with roofs that are a little not straight and simple, and or have some shading in some part of it. So they're a little more capable. Then we need racking to hold it in place, and we're going to typically use aluminum racking. The simple thing to do is on a shingled roof, you just screw lag bolts into the underlying roof. If you're doing other types of roofs, Blair's going to talk about some of the other ones, but metal roofs are also very doable. If your roof doesn't work, you can also do a ground mount system, but you have to realize that cost will include extra components because you've got to put in some kind of piers or foundation and some kind of structure. And typically you also have trenching and long distance conduit you have to run out to the system. So all of those costs are more than the simple ones we talked about already. Of course, you have wiring to hook it all up, and you got to ground it and bond it carefully. Claire's going to talk about that as we go through the details. You may want to have an extra power meter that looks the same as your electric meter from a utility, but is added to the system so that you can watch it produce and count just the production, not the net of the excess between the sum of generated and usage. So just production, so we call it a production meter. Some systems, and the microinverters all come with it too, have an optional component you can add to the system to do remote monitoring, so that it's connected to the internet, and they'll have a website or an application for your smartphone. You can look at that website, look at that app, and get an instantaneous calculation of how much energy you're producing right now. And if anybody wants to see one of those, I can pull up my phone and show you my system. So those are the basics of the components. And we are talking about a grid-tied system that's hooked to the utility and a battery-less system. So there is no storage of electricity here. And if you're interested in battery systems, there are typically two other purposes for battery systems. One is to go totally off-grid, where you disconnect from the utility if you're not hooked to the grid at all. That's a real lifestyle change to do that, okay? Because this system only produces electricity for a few hours every day. You've got to manage your load very, very carefully to be off-grid. Or you can also put a battery on a grid-tied system. All of this is extra money because storage is, batteries are costly, although the prices are coming down in the last year. But they're still much higher, at least $1.50 extra per watt. And it's really a different dimension, we should say, per watt. So recognize that without batteries, these systems do not operate when the grid goes down. Okay? There are several major safety reasons for that. Just like when you have a generator at home, when the grid goes down, you don't want to feed the energy you're generating on your generator out onto the grid and have a wireman out there get electrocuted by backfeeding while he thinks his system's down. So by the UL standards, these systems do not work when the grid is down. Now, there are some alternate systems that have a transfer switch and things like that, but those are more expensive systems and are not the microinverter systems. So that's all we're going to cover for batteries today. Any questions? Yes?
Just one quick question that you're on that subject. What about backup generators? Can they be utilized with, I have a backup generator?
Yeah, almost all of them will not generate enough of a good sine wave.
No, that's not what I mean. In other words, when my backup generator kicks on, is it going to affect these panels?
No.
No.
Oh, okay.
Because the generator's sine wave, the energy it produces won't be a nice smooth wave like a utility. The inverters can sense that. It's not utility power, it's some other power, and they won't operate. They're going to turn off.
No, I'm saying they go on hertz.
Yeah, well, it's not just hertz, it's the shape of the wave.
Thank you.
Yeah. It's most of the generators we sell today are not good, clean sine waves.
Yeah.
Yes.
There's a 25-year warranty or microinverter.
That varies by manufacturer. The 25-year warranty is a production warranty, which means they have a calculation of how much they degrade in their production over 25 years. Most of the component warranty, if it breaks in some other way, is 10 to 15, depending on the manufacturer. Okay?
I assume the output then is high voltage.
Yeah, when you convert to AC, it's 60 hertz, 120 or 240, typically 240. Okay, yes?
If you have separate panels, how do you know when one of them goes down?
That's one of the benefits of the online remote monitoring. When you do the remote monitoring, Each of these boxes reports individually. So you'll actually get a panel by panel view of the microinverters. And if any one is not producing, you can say that it's producing 0 or less than the others in the same group. If you don't have that, the only way to do it is to see that your production is not as consistent from month to month or year to year, and then get up with the whole, and we'll talk a little bit about that later.
Okay, that's just an app or your smartphone.
Yeah, or a website to visit on there. to see it. You can buy extra boxes to display as a dedicated display, but I don't think many people do that. Okay?